So here we go. We got the lesson recorded. Let's start filling out some of these points, okay? So we come back to the circle of life, okay? So this first point you guys all indicated was 1, 0. So what was this one up top? 0, 1. Good. How about this coordinate over there?
-1, 0.
And on the bottom? 0, -1. Excellent. So we have our different degrees. We've got 0, 90, 180, 270, so on and so forth. Let's pick off some of these other points. Did you come up with this guy here? Good. We've got that terminal point ready to go. And that is for what kind of angle? 45 degrees. So how about this one right here? What comes first, the root of 3 over 2 or 1/2? Root of 3 over 2, that's the larger value, and you could tell the x value is going to be larger than the y value. So we got root of 3 over 2, and we got 1/2. And then it switches up here to 1/2 and root of 3 over 2.
Roll the other way around for the entire thing.
So you switched them up? Is that what you mean?
Yeah, for everyone, like instead of root of 2, I put instead of root of 3 over 2, I put 1/2, instead of 1/2, I put 3 over 2.
Okay, okay, we definitely want to change that then, okay? So this is a 30-degree angle, this is a 60-degree angle, this is a 90-degree angle. Now, we're not going to do the whole thing, but the idea is that you know enough to where you could complete the unit circle. It's sitting up there in your brain. We're just going to kind of prime your brain a little bit. This is 120 degrees. Who could tell me what that coordinate would be there? We've got a lot of things laid out, so what's this one going to be? -1/2 and root of 3 over 2. Good. And then how about this one here? Yeah, good. So for 135 degrees, that's again a 45 degree reference angle. That's going to produce, as you said, negative root of 2 over 2 and positive root of 2 over 2. So we're just, the quadrants changing our values, right? And then this last one, 150 degrees, is going to be? Yeah, good. So, I mean, today is not, it's not like, I wouldn't say today is like a super easy day necessarily, but it is going to make sense to you. It's going to jive. It's new, though, okay? And I adjusted this lesson this year. I've just always been unhappy with coming up with certain values, and I think it worked well first hour. So we're going to start with kind of the basic idea of what we're trying to do, okay? So let's look at an easy equation. Suppose I had an equation of x equals 4. What's the solution to x equals 4? 4, right? We're all on the same page here? So what's different now is our equation. This is sine of x is equal to 0. So what it means is, what angle do you take the sine of to produce 0? So we're trying to solve for x. And so this is really asking, when is there a y value of 0? For what angles do we have a y value of 0, Luke? 0 degrees and 180 degrees. And I'm going to go all the way around to 360. We're going to solve for angles between 0, 180, and 0 and 360, okay? Now, you could continue to head around and around and around, couldn't you? Like 720 would be in that same spot, okay? Right? 1080 would be in that same spot. We're not going to represent all those solutions, but we'll represent those between 0 and 360. So let's look at the next one. Sine of what angle produces 1? Yeah, 90 degrees. You see that the y value is 1 at 90 degrees. So this solution is 90. So look at the first one had 3 solutions. The second one had 1 solution. So the fundamental theorem of algebra states that if you look at the degree of the polynomial, that tells you the number of solutions, right? So if you see x to the third, how many solutions are you going to have? 3. But that's when you have a polynomial represented. These are not polynomials. These are trig functions. So we can't necessarily know ahead of time exactly how many solutions we're going to get. When is sine of x equal to -1? 270 degrees. Good. So 1 solution. So now we move to cosine. So if I move into cosine, am I looking at the x value or the y value? X value. When's the x value 0? Good. 90 and 270. So that one had 2 solutions. Cosine equal to 1. So when is the x value 1? 0 and 360. Good. 2 solutions there. Yep. 0 degrees is funny to write. It's hilarious. I laugh every time. Cosine is equal to -1. When is the x value -1? 180. Good. So you've dealt with sine and cosine. You've dealt with some of these kind of important values, and we could just kind of think of them. We don't need our calculator. No big deal. Uh-oh, tangent. Tangent is the y value divided by the x value. So let's look. When do you take y divided by x and come up with 0? Okay, how about 90? No, that's undefined, right? So we got 0, 180. Yeah, 0, 180, and 360. So that's 3 solutions. 0 degrees, 180 degrees, 360 degrees. Good. Okay, so now let's try to think about this. When is tangent equal to 1? So that would mean if you took y divided by x, you get the same thing, right? 45 and 225. So in the quadrant where they're both positive, in the quadrant where they're both negative, right? So we've got 45 degrees and we've got 225 degrees. So tangent of x is equal to -1. So when we have the same values, but we divide them and they're opposite values. Close, 315. Right, good. 135 and 315. Nice job. You guys are smart. It's like we learned something this semester. Oh boy, sine 1/2, -1/2. We don't actually have that up here on the board. Let's think about it for a second. Where is sine negative? Which quadrants? Yeah, the bottom two, right? So, Luke, when are you seeing that it's going to be -1/2? Yeah, so Luke is saying, well, when you go down here to those spots, that's when the y values could be -1/2. He's right. So 210 and 330, those are the spots. And you guys, we're going to show you a little bit more of like a process by which we find these out instead of just thinking about it. But we're trying to prime your brain for the other things. Yeah.
Mind if I go to my pencil?
You go do that. Okay, so now we got cosine of x is -√3 over 2. So where is cosine negative? Yeah, 2 and 3, that's where the x value is negative. And then -√3 over 2, when is the x value -√3 over 2? Oh, it looks like the 150 mark there, and then where else would it be? Yeah, 150 and 210. And now look at number 12. Is there a nice value for where tangent's equal to 2 or -2? There's not, is there? There's not. So what we've shown you is some nice values that come up that we can kind of just look at the unit circle and figure it out. But for most situations, you're not going to come out with these just super nice values, and you need your calculator. So take out your calculator, okay? Yo. My favorite color is blue. When it comes to calculators, I do not discriminate. Calculators are wonderful. No, I should not say that. Not a big fan of the Casios, right? Right, Ms. Rubel? Am I right? Exactly. Yeah. Yep. We say Texas Instruments kind of has the market on the calculator. That's kind of where we're at. Yeah. TI. Yep. I have expensive taste. Yeah. All right. Let's go. All right. Here we go. Let's figure out where tangent is equal to -2. This is where we really need to hone in and make sure we're understanding what the heck we're doing. First of all, I determine when is tangent negative. Which quadrants? 2 and 4. Good. Hold on, you guys. People are answering. I don't know what you're thinking. Okay. How are people determining 2 and 4? What do you? That's what you're using. Okay. Okay. That's fine. You do whatever you do. So well, kind of. When I think of tangent, I think of positive, and I think of negative. So since tangent is y divided by x, it's going to be positive here, it's going to be positive here, and then since these are opposite signs, that's where it's going to be negative. So I do always think of actually the positive and negatives. A lot of students turn to all students take calculus, which is kind of a thing, but I think about the positive and negative quadrants. I really do. Okay, so we determine where it's negative. Now, if you take out your calculator here, and we go into mode, make sure you're working in degrees. We're going to answer these questions in degrees, not radians. Okay, you should be in degrees because it wasn't too long ago we did the law of sines and cosines, stuff like that. So if you're in degrees, what I do then is I go tangent inverse of 2. Don't type in the negative. You used up the negative when you determine the quadrant. And then press enter, and we get 6343. Now, this is really important. 6343 is not the answer. Okay, you got the right idea, but it's not 100% correct. 6343 is the reference angle, and it must be formed against the x-axis. So 6343 goes here. It does not go against, it never goes against the y-axis. So when you draw that little reference angle, always put it so it butts up against the x-axis. Now let's determine these angles. Okay, the answer is not 6343. The answer is this red arc that I've drawn. How can I compute that angle right there? Subtract it from 180. Oh, so I see what you were doing. You were figuring out this one, and then oh, I got you. Okay, so we're just gonna subtract it from 180. Let's do that. 180 minus 63.43 is 116.67? 57. And then, how are we going to determine the other red one?
Take 160.57 and put it against 360 degrees. Or add 180.
Okay, so you're right. There's multiple ways to think about it. You could add 180. I'm gonna encourage you to take 360 and subtract 63.43. Okay, it's 63.43 short of 360, and you get what? 296.57 degrees. So you can see that sometimes you come up with angles that are not always as simple as looking at the unit circle. Sir?
So all you do is take the inverse root of it, and,
Yes.
and then put it against 180 and then against 360.
Not always against 180 and 360. It just happened to be that way for tangent. Watch how this one works out here. Okay, so now we're going to solve an equation between 0 and 360. What do you think my first step is?
It's side by itself.
Yeah, so I'm going to add 1. 2 sine of theta is equal to -1. What are you going to do now? So sine of theta is equal to -1/2. Was that difficult? So notice my anger when I get to that spot on the test and people don't add 1 or divide by 2. Can you see how I could be furious at that point? So please don't do that to me, okay? All right. So now we got to figure out where sine is negative. So at this point, when you want to solve that, you set up your quadrants. Sine is negative where? 3 and 4. It's the y value, so we're looking for where y is negative. Okay, I go to my calculator, and what do I press? Yep, inverse sine or second sine. Don't put in the negative. We already used up the negative. Put in just 0.5. No. Always put in a positive value when you inverse. Yeah, so it's 180 plus 30 this time, which is 210. 360 minus 30 is 330. So Easton, in this situation, we did go against 180 and 360, but instead of subtracting from 180, we added. Just it depends on if it's past 180 or behind 180. Okay? All right, the next one, what are we going to do first? Add 4, so we get -5 cosine of theta is equal to dos, which is Spanish for 2. You're welcome. And then cosine of theta is -2/5. What now? No. What first? Where is it negative? 2 and 3. So see, in this situation, we did not go against 360. We're against 180 on both sides. So it's different depending on which trig function is being used and whether it's positive or negative. Okay, now what do we do?
Take the inverse cosine of 0.4.
Yep, okay, 0.4 or 2/5, good. I don't use the negative. I've already used up the negative by determining the quadrants. I got 66/42. I always put it against the x-axis. Don't tell me the answers. Tell me how to compute the answer.
180
Okay, 180 minus 66.42, and you get 113.58. And then add 66.42, and you get 246.42 degrees.
So for this, you're putting it minus 180 because it's past 180.
So this one, we subtract 180 because it's behind 180. And for this one, we add 180 because it's past 180. Yep. Flip it over. By the way, solving trig equations, we can look at kind of easier options and more challenging options. So we're really kind of going over the easier options today. Okay, so we'll visit this again and extend later. Okay, you try this one on your own. Go. You do this one on your own. You can do it. Go. Where? This? No, that's some statistics. We're talking a little bit about normal distribution today and heights. We're seeing if people were really the heights that they thought they were, and then we're guessing like what percentile they're in. But yeah, a little bit of normal distribution talk. Yeah, I don't do that. Okay, here we go. All right. So I got 5313 and 223.13. Everybody get that? Okay, so what's different about the next one? Okay, I got cotangent, I got more things, right? So let's forget about the cotangent. Just if this was a normal equation, what would you do to solve it? Yeah, you'd say -6 cotangent of theta plus 6 plus 3. I'm sorry. Yep. So plus 3 plus 3. Yep, very good. Equals 6 minus 2 cotangent of theta minus 1. So, you know, cotangent of theta is just, it's like a variable. And so, if it was an x, what would you do in that situation? You would just, yeah, you'd try to get it by itself. But you start by combining some like terms, right? So, as Sydney said, 3 plus 3 is 6. And then the 6 minus 1 is the 5. So I got cotangents on both sides, kind of like you have x's on both sides. What would you do now? Okay, so you add 2, so you get -4 cotangent over here. And then you subtract the 6, you get -1. And then what would you do? So you get cotangent is equal to positive 1/4. So that looks pretty good, except for the fact I don't have a cotangent button on my calculator. Very good. So we just treat tangent of theta is equal to 4. So you just switch it. You got a tangent button, so just take the reciprocal. Yep, look at Elle. She's so smart. So let's set up our quadrants. Where's tangent positive? 1 and 3. Tangent inverse of 4, and as Marissa said, we got 75/96. And then what after that?
55.96.
Good. Yep, 55.96. Good. You're doing well. So number 5, what would you do first?
Subtract 3 cosecant.
So cosecant of x is equal to 3. close. What's the reciprocal of cosecant? Sine of x is equal to 1/3. Where is sine positive? 1 and 2. Go to my handy dandy calculator. 1947. You know, it's interesting. Somebody claimed that they were born in 1947. I am not that old. So obviously 1947 is one of the angles. The other one is good. All right, you've kind of covered the basics. We're going to step forward just a little bit. Nothing too complicated, but you definitely need to see example 6. This one's nice and easy. What are you going to do to both sides? So you get 11 cosine of x is equal to 17. Then cosine of x is 17 over 11. Any thoughts about that? Why does that not work? Don't say it's because it involves 17 and 11. It's more than 1. And can cosine ever be more than 1?
No.
Can sine ever be more than 1? No. Can tangent ever be more than 1? Yeah. So tangent can be more than 1, but sine and cosine cannot. So if you end up with this, what's the answer?
No solution.
No solution.
I love those problems.
Yep, you love the no solution problems.
This looks like you don't have to look to work and you're like,
Yeah. Now, what about number 7? What's different about that?
that's squared.
It's got a squared. We'll just solve it normally. What are you going to do?
3 secant squared of theta equals
12.
divide by 3.
Good, divide by 3. So I get secant squared of theta is 4.
Then take the square root.
So I get secant of theta is plus or minus 2.
Plus or minus.
Yep, got to do the plus or minus.
That would be a cosine theta equals plus or minus 1/2.
Good job, Easton. So cosine theta is plus or minus 1/2. So we're not just looking where cosine is positive, we're also looking where cosine is negative. So in which quadrants is cosine positive? And where is it negative? 2 and 3. So as Avery said, we're going to have answers in all of the quadrants. So how many answers are you going to have? 4. So once again, you can't make a really strong prediction all the time how many solutions you're going to get. So if I inverse cosine of 1/2, you do get 60. Please make sure that you always draw the angle against the x-axis as you produce these results. So I built these problems to have the answer 60 in it for your enjoyment.
Really?
Yes, I did.
That is amazing, guys. We love you. I think we should 120. Yeah, we should.
Yeah, so we got 180 minus 60 is 120, right?
Yeah.
Yep, 240 and 300. All right, cool. The next one's squared, but it's got multiple tangents.
You can take that tangent.
Factor out a tangent. I like your idea. Let's do it. Tangent of theta times what's left over? 2 tangent of theta plus 1. Great. So now I'm setting up the zero product property here, and I have 2 equations I'm now solving. The first equation is tangent of theta is equal to 0. Now, when you come up with some of those types of values, we already talked about those at the beginning of class, didn't we? Where was tangent equal to 0? That was when y divided by x was 0. When did that happen? 0 degrees, 180, and, yep, if 0 works, so does 360. And then, what's the other equation we'll solve for? 2 tangent of theta plus 1 is equal to 0. Or in other words, tangent of theta equal to negative 1/2. Where is tangent negative? Good, 2 and 4. Get it right eventually.
Eventually was right.
What do you type into your calculator? Yep, a 0.5. Don't use the negative. Now you get 2656.
Oh my gosh. These are the ones that comes every single day. Yes, it was very. I don't know what that ever.
How do I figure out my first one?
Subtract 180.
And you get?
153.44 degrees.
And then the other one will be? Good. All right, we got 2 left. You guys are doing a nice job. Number 9. Thoughts? One of the most common attempts that people make in these situations is to move the 4 to the other side. I need to caution everybody in that, again, we have a 0 product property. We don't have a 4 product property, do we? There's no 19 product property. There's no -8 product property. So we like it when 0's on the other side. Because if you have something times something and you get 0, you know one of those two things needs to be 0, right? So that's what we're using. So this does factor as a trinomial. Yep. And what are we going to start off with? 5 cosine of theta times cosine of theta. Okay, so Riz is saying, it's either going to be a 1 and 4, or 4 and 1, or a 2 and a 2. Yep, it's going to be a 4 and a 1. So now we have 2 equations to look at. And this one, we have cosine of theta is equal to -1. We already determined that on the previous page. When is cosine equal to -1? 180 degrees. Again, we're asking when is the x value -1? As you look at your unit circle, that's what you got. The next one we're trying to solve for is when is cosine of theta equal to -4/5. So I set up my quadrants. When is cosine negative? Good. Luke's on the ball. I inverse 4/5 for cosine, and you get 36.87. I've just gotten used to the numbers. It makes, this comes from a 3, 4, 5 right triangle. And over the year. Stop it. Don't, no, see, now I feel like you're judging me. No, now I feel, it's okay. All right, it's okay. It's okay.
That's official, thank you.
No, I'm. Okay. I'm comfortable with who I am. So here we go. So we're going to subtract 3687, and we get 143.13. If we add 3687, we get 0.87. Good. So our last example, and notice that this has 3 solutions. So that whole idea of, well, there's either going to be 2 or 4 or whatever. No, you just got to see the problem through. What do you want to do for number 10?
Take out a sine.
Good. Let's factor out sine. And what are you left with? Minus root of 3. So we have 2 equations that we're trying to solve. The first one is when is sine of theta equal to 0? And we have determined that.
It was 0 and
180, 360.
180 and 360, good. You guys are sharp. And then when tangent is equal to the root of 3. And when tangent's equal to the root of 3, that's positive. So which quadrants? 1 and 3. Can anybody figure it out without inversing it? Yeah, it is 60. See, I made these problems for you guys.
what is the tangent of 45?
1.
Because remember, it's the 2 roots.
So I get 60 degrees as well, and I get 240 degrees. So as you notice, this one had 3 solutions. This one has 5.
That's a lot of solutions.
It's a lot of solutions. So if you want to kind of be caught up with this class, make sure that this was done by Monday. Okay, tomorrow's Friday. You don't have to finish it tonight, but by Monday, make sure that you kind of have some of these answers checked and ready to ask questions. And yeah, so good job. We'll go over the answers for your practice test I gave you tomorrow at the beginning of class, and then be ready to start practicing more from there. What's that? Track meet is on Tuesday this next week. Today is the 24th.